So let's look at how we figure out angles where we've got parallel lines involved. So there's several different rules that we need to know when we're working with parallel lines. Some of them I've already covered in a previous video, things like angles on a straight line or opposite angles are equal, things like that. So don't forget all those more basic facts about angles we know, but we're going to introduce now 3 different ones that are special just to parallel lines. So they only work with parallel lines. So looking at this diagram here, they're asking us to find this angle at the top here. And they've told us this angle here is 72 degrees. Now compared to the parallel lines, which are here, these 2 angles are in the exact same position above the parallel line and this side of the line that's going through them. So those 2 are equal. So that means that this angle up here is also 72 degrees. And then it asks us to give our reason. So this is where we need to know the name of this rule. So when they're in the same position like this, they are called corresponding angles. Okay, so corresponding angles are equal. That's what we're saying here. So let's introduce another rule. So we've got parallel lines coming this way this time, and in this side we've got 60 degrees, and in this bit here is y, the one that they want us to find. Now these ones are on opposite sides of the line here, so it's not corresponding, they were both on the same side. So these 2 are also equal, but for a different reason. So that means this angle here is also 60, but the reason for this is that these are called alternating angles. And that makes some sense if you think about what we mean by alternating. So we've got one angle on this side and the other angle on the other side. Notice they are both in between the parallel lines. So that's alternating angles. Okay, put that one to one side for a minute. So we're going to introduce the 3rd one that you need to know about that's special to parallel lines. So here we've got our parallel lines going up this way and a line coming across. And in here we've got X. And in here we've got an angle which is 111. Okay. So this is, both angles are inside and on the same side of the line that's going through. But unlike with the corresponding, they're not in the same positions. So this one is this side of this line, but this one is a different side. So this is almost the odd one out here. Let me just, sorry. So alternating angles are equal. So here we've got a different rule. And the rule is here that these add up to 180. So in order to find our missing angle here, we're going to have to do 180 take away 111. If it was 180 take away 110, it would be 70, but we actually need to take one more away, so that makes it 69. Okay, so give a reason for your answer. So there's a couple of different names that people use. I've always called them supplementary angles. And remember, these ones aren't equal, but they equal 180 when you add them together. Now, the other name that I've seen for these is interior angles. Okay, so those are our 3 ones. So now we're going to look at some more examples just to show how it works, because sometimes you need to use a combination of those and some of the basic facts we've done before with angles. So in this picture here, we've got parallel lines here, and they've told us this angle here is 59, and they want us to work out what this one is. Now this does not match any of the pictures we've just shown, so we're going to have to do it in stages. And it does ask you to give reasons for your answer, so you need to give reasons for each part of what you do. So the first thing that I'm going to use is the corresponding angles idea. So this angle here corresponds with this angle here. So this angle here is also 59. So the first thing I've done here in my reasons is corresponding. Okay, I'm abbreviating here. You need to write a bit more if it's yours, to explain that those are corresponding angles, therefore they were equal. And then the final step that we've got here is now this angle and this angle are on a straight line, so they equal 180. So we're going to do 180 take away 59. 180 take away 60 would be 120. We've taken too much away, so we add one back, so it's 121 degrees. And to finish this off down here, our reason for doing this is that angles on a straight line equal 180 degrees. That's how we did the second part. So let's look at a few more. Okay, let's keep those separate just so we might be able to use those. So here we've got two parallel lines going here. We're told that this angle in here is 135. This angle here they're calling X, and this angle here they're calling Y. So we've got two angles to find. So the first one we're going to find is X, and if we look at this, hopefully you can see this is an example of what we've used here in this one. They're both inside on the same side of the line, so they're supplementary, which means they add up to 180. So to work out what X is, we need to do 180 take away the 135, and that is going to give us 45 degrees. So as I say, that's because those are supplementary or interior. Okay, so next we're going to work out what Y is, and Y is going to be the same as X because those are opposite angles. Okay, so Y is also 45 degrees, but the reason this time is because those are opposite angles that are equal. Okay. Here we have another diagram. So our parallel lines are going here. This angle up here is 65. This angle inside here is 105. And then we've got X and Y here to find. So it asks us to work out what X is first of all. So here's X, and it corresponds with this X up here. So X is 105, and the reason is that they are corresponding. So now we've got to work out what Y is. Now be careful, these two are not supplementary. Okay, try and show you this one with supplementary again. Look, these two are supplementary because they were between the parallel lines. These two are not between parallel lines, so that's not supplementary that we can use there. Okay, so if, however, we knew what this angle was on this side, we could use angles on a straight line. And we can work out what that is because this angle is corresponding with this angle, so this angle is also 65. So then we use angles on a straight line to work out what Y is. So it's 100 minus the 65. Sorry, why am I saying 100? 180, sorry, angles on a straight line, isn't it? 180, take away the 65. So that will be 115 degrees there. Okay. Just going to do 2 more just to show how they can be combined. Okay. So our parallel lines are going here. We've got an angle here of 154 degrees. Now we've also got some important markings on here. Let me just, that's Y over there, that's what we're trying to find. But on here we've got a little triangle in the middle there that's got these 2 lines on. So that means that those sides are the same, which means that that triangle is an isosceles triangle. And that's obviously going to be useful for us in here. Okay, so how are we going to solve this? This is a 4-mark question, so expect it to take a few moves to do it. So the first thing I'm going to do is the fact that this angle here corresponds with this angle up here. So this angle up here is also 144. It says give you reasons, so the first thing we've done is use corresponding. As I say, I'm being a bit short-handed here. I would write a bit more than that if I was doing it. So now I'm going to look at the fact if that is 154 there, this angle is opposite, so it's also 154. So now I've used the opposite angles rule. So notice every time I work one out, I'm writing down the reason behind it. If you do that in an exam, then you won't miss something out. Now the final thing we've got here is that we've got an isosceles triangle. So that means that this angle here and this angle here are the same. And we know that angles in a triangle add up to 180. So if we do 180 minus 154, that's going to give us 26 degrees. So these 2 angles must add up to 26 degrees, and because they're the same, we know, therefore, by dividing by 2, that each of those angles is 13 degrees. So, if you like, our step 3 here is use 2 things. So we've used the fact that angles in a triangle equal 180, and we've used the fact that it's an isosceles triangle to get the other, to split these angles apart because they've got 2 equal angles. Okay, so as I say, I'm writing that in shorthand. I did it longer before. So now we know that this angle in here is 13 degrees. We can finally work out what Y is because they're on a straight line next to each other. So we're going to do 180, take away 13, which is going to give us 167. So that's our Y. Now, typically I would have done these sums more in line with the reasons, okay, but I'm just trying to keep it neat here. So our the fourth thing we've done and used is now angles on a straight line equal 180. So this had 4 marks. So there were 4 moves here, if you like, and 4 reasons to go with them. So final example. Okay, so our parallel lines are here this time, and they're asking us to work out this angle at the bottom that they've called X. This one inside at the top is 51, and this one outside here is 116. So we've got a great big triangle here. We know this angle, we want to find that angle. So if we could work out what this angle is here, we could use angles in a triangle to figure that out. So we're working on trying to establish what that angle is. Now the clue to how we're going to do this is that this angle here, because these are parallel lines, will be the same as this angle up here because they are corresponding angles. Okay? So how can we work out this angle? We can work it out because these two angles are on a straight line. So we're going to do 180 minus 116, which is going to give us 64 degrees. So that means that this angle and this angle are 64 degrees. Now we know this angle. We know this one at the top, so we can work out what this one is. So we add the 64 and the 51 together. That's going to give us 115 degrees. And then we take that away from the 180. And that's going to give us 65 degrees. So X is 65 degrees. They haven't actually asked us to give reasons here, but they have said that we need to show all our workings out. So actually you'd probably need to explain up here that how you worked out that these were both 64. So that's how we work with the parallel line rules.